Section 5, we're going to look at using inequalities within a single triangle. Example number 1 says mark the largest angle, okay, the longest side, the smallest angle, and the shortest side of the triangle shown below. What do you notice? Okay. So here's the thing. I'm going to go ahead and just mark this using red. So to me, and again, this is a little bit goofy because we don't know the exact angle measures, but I think it's pretty clear that this angle is going to be the largest angle. I think it's pretty clear that this is the longest side. And so if you notice here, the longest side and the largest angle are opposite each other, okay, or across from each other. The way it's written here, you'd say opposite each other. Oftentimes I'll just say across from each other, same idea. I mean the same thing, okay? And the smallest angle here appears to be this one to me. And then the smallest side appears to be this guy. And so what you notice again is the shortest side and the smallest angle are again opposite each other. Okay, and so that's the first big idea in today's lesson, is that if one side of a triangle is longer than another side, then the angle opposite the longer side is greater than the angle opposite the shorter side. Okay, so in this diagram, since we know AB is longer than BC, that automatically means that angle C has to be bigger than angle A. Okay, and hopefully that makes sense, right? I mean, the bigger the opening, the longer the side is going to be. And when I say the bigger the opening, what I'm really saying is the bigger the angle, the longer the side. Okay, if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than. So we're just going the other way now. It's essentially the converse. Okay, so in this diagram, we don't know exact lengths, but what I do know is that the length of BC, whatever that is, has to be bigger than the length of AB. Okay, because of the fact I know that this 50 corresponds with that side, and this 30 corresponds with this side. So it says list the sides of PQR in order from shortest to longest. So all you're doing is identifying angles first. So your smallest angle is 45, which means your shortest side is QR. So QR is your shortest. PQ is your middle side. And your longest side here is obviously going to be PR because it's across from the 80. So pretty basic idea. That's what we're looking at. Okay, it says a long-tailed boat leaves a dock and travels 2,500 feet to a cave, 5,000 feet to a beach, then 6,000 feet back to the dock as shown below. One of the angles in the path is about 55 and one is about 24. What is the angle measure of the path made at the cave? Okay, and so really what you have to identify here is, okay, clearly the 24 is going to be the smallest angle in the diagram, and therefore it's got to be across from the smallest side, which means the angle here that it made with the beach has to be 24 degrees. The 55, I mean, you can figure out what the third angle has to be here, right? So you have 55 plus 24, that's 79 degrees, and when you take 180 minus 79, the biggest angle here has to be 101, and obviously the largest angle has got to be the one at the cave because it's across from the longest side. And so really to answer the question, what is the angle measure of the path made at the cave? It's very simply 101. What you had to identify was, you could tell right away that it's either got to be the 101 or the 79, but again, it all goes back to the fact that 6,000 is bigger than 5,000, so the angle has to be bigger. Okay, this is a huge theorem that we'll use a lot in the remainder of this course. It says it's the triangle inequality theorem. It says the sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. So in other words, there's three cases. AB plus BC has to be bigger than AC. AC plus BC has to be greater than AC. Well, I just said that, didn't I? No, AC plus BC has to be greater than AB. Lost track there for a second. And then finally, AC plus AB has to be greater than BC. So you have three different scenarios you can check. There's actually a shortcut here once we get rolling that I'll show you. But that's the idea behind the triangle inequality. Take the sum of any two sides. It's got to be strictly greater than, not greater than or equal to, strictly greater than the third side. So can the following sets of three lengths form a triangle? All right. Now, what some people would do is they'd say, okay, so I gotta do 10 plus 7 is greater than 9. I also have to do 10 plus 9 is greater than 7, and then I gotta do 9 plus 7 is greater than 10. Okay. And what I'm going to tell you is you don't actually have to look at all three. Okay. You can scrap the first two. Because think about this. All right. In the first two, the longest side here, which is 10, is on the left-hand side of the inequality. Well, 10 all by itself is going to be bigger than 9, and it's also all by itself bigger than 7. Okay, so you don't have to consider the case where the longest side is on the left-hand side of the inequality, because that will always be true. The only case you really have to test is whether or not the two short sides add up to be bigger than the longest side. And so here you have 9 plus 7 is greater than 10. That's 16 bigger than 10. So your answer here would be yes. In the second one, you don't have to do 4 plus 6 greater than 1. All you have to do is look at the only inequality you have to check is 4 plus 1 greater than 6. Well, that's 5 is greater than 6. Clearly, the answer to that question is no. 9 plus 8 greater than 12. Well, that's 17 bigger than 12. That makes sense. That's yes. And then we have 4 plus 4 is bigger than 9. That's 8 is greater than 9. And again, I think we all agree that that's no. So that's a very basic application of the triangle inequality. Example 5 says a triangle has one side length of 14, another of 10. Describe the possible length of the third side. So just draw a quick picture, right? So here's 14, here's 10, call this guy x. Okay? What I'm going to tell you is you have to assume two cases. The first is assume that x is the shortest side. Okay? If x is the shortest side, well then the inequality that you would have to test would be the short side plus the middle side is greater than the longest side. All right, and when you solve that, you subtract 10 from both sides, and what you end up getting is x is greater than 4. Okay, so we know for sure x has to be bigger than 4. The second scenario I'm going to tell you you have to check is you have to assume that x is now the longest side. If x is the longest side, then the inequality that has to be true is that 14 plus 10 has to be greater than x. So that's 24 is bigger than x. All right, and when you look at these two inequalities that we came up with and how they're related, one says x is bigger than 4, the other one says x is smaller than 24. And so your final answer should be written as a compound inequality saying that x can be anywhere between 4 and 24. Okay, those are all the possible lengths of that third side. Can't be less than 4, can't even equal 4. If it's 4, then you don't have a triangle. If it's 24, you don't have a triangle. But any value in between there will work. Really, the length of x is all strictly dependent on this angle. Okay, the bigger the angle, the longer x will be. So again, go ahead and I would pause the video here and try this one on your own. And I'm going to go ahead and do it anyway. So if you want to just stay with me, that's fine too. So again, I'm going to assume that x is the smallest side first. So x plus 17 has to be greater than 23. So I subtract my 17 from both sides. So x has to be bigger than 6. And then I'm going to assume that x is the longest side. So this says what? 40 is greater than x. So in other words, your final answer, x has to be somewhere between 6 and 40. All right, and so that's all we're looking at here with the triangle inequality. We can make things a little bit more complicated by adding in a different expression. Instead of just using x, we might use x plus 2 or x squared minus 7 or whatever. That can make things a little bit more complicated algebraically, but really the basic foundation behind the triangle inequality is what you've seen in this video. So as always, if there's anything here that's confusing or you're not sure of, bring it to class and we'll make sure we discuss it.